I'm Kim Libreri, CTO of Epic Games. Been at Epic for a couple of years, responsible for the sort of mix between creative and technical stuff that we do at Epic. So on Paragon, which is Epic's MOBA, that actually is in early access right now and is going to go for wide distribution later in the year, we wanted something special to be able to launch the game with, and also as a forcing function to really lock down what the art style was going to be of the game. The game's very character focused. You play a variety of different heroes in the game, and we really wanted to be able to tell a story where you get to see the amazing capabilities of the heroes and the lush environment of the world. So, best way to do that at first, other than making a cool game that people want to play and they experience, is to do some cinematic content. And it also, because we have a history of doing great cinematics at Epic, always in our engine, always real time. It sort of allowed us to set the visual bar for this is how good we want the game to look. We started off, I think it was September last year. We had about a 12-week production schedule to put the thing together, and we went from some basic ideas of what we thought the game was going to be. The art team, led by my good friend Jordan Walker back at Epic and Chris Perner, sort of were roughing out what the world was going to look like. But the cinematic sort of, because obviously you go from shot to shot to shot in a cinematic, was able to sort of dictate, hey, let's finish this area first because we want a piece of action in this cool part of the game. The other cool thing about it was we have a new cinematics tool, Sequencer, and we needed something to sort of be the test bed so that when we release it, we know it actually works well. So Paragon, or the Paragon announce trailer, became the test bed for Sequencer. Every asset in that trailer is an asset from the game, so the characters are the highest level of detail of the game assets that we have. The effects are the effects from the game, and actually, as I said earlier, the effects. What we did in the trailer informed what we would actually have in the final game. So we took content that was in the game at that point, in the early days when we were doing the cinematic, refined it for the cinematic, and then put it back in the game. Everything we do is inside our engine. They're the real components. Every artist that worked on modeling, texturing, doing the effects work, doing the lighting, are actually the game art team as well. So we don't have, we have a few people in our cinematics team, but the majority of people that come on to get these things done are from the game team. So it's absolutely authentically Paragon. And what you see in that trailer is what you see in the game. Admittedly, it's on a very high-end PC when we render the cinematics, but the content is the same content. The actual content creation tools we use are pretty much the same things you would use in visual effects. Maya, 3D Studio Max, Mari, Substance Painter, a lot of overlap. The main difference on the asset creation side of things is that we have to really be wary of our polygon count and our texture resolution and how many textures we use. So there's a little bit of extra thought goes into making sure that we make as efficient asset as possible, but we still start with very high resolution models that will then decimate down into something that is more suitable for the engine. We also tend to always generate LODs. We have to. We have to scale from a low-end PC through an awesome PlayStation 4 all the way up to high-end state-of-the-art PCs. And obviously, they all have different capabilities. So the content itself has to be made at different resolutions, and then you can specify which level of detail you use for a particular platform, and also for a particular placement within the level. If something's far away, use low-resolution LOD. If it's close, use the high-resolution LOD. I think on the rendering side, and particularly the movie side of rendering, we're getting pretty close to knowing what it takes to make something look perfect. It's always been a question of level of detail. The smallest pore, the smallest little bit of hair, all these things really add up to what makes something look real. We're beginning to do a pretty good job of understanding the motion, how a face goes from one shape to another shape, and how the muscles affect the deformations of the flesh and the fat and the skin. And actually, the techniques that we use in real time are not that different from what the movie industry is doing. We're lacking a layer of simulation that the movie companies would put on the top of their actual face animation. But I think the place that we're missing is really being able to completely decode the fundamental principles of motion within a face. But we're getting close. I think within 5 years, I think the movie business is going to pretty much cross it. There's a lot of new science. We have all that deep learning stuff nowadays, and many databases of different face types. So I think the problem is going to get a lot easier to solve. The biggest challenge for us in the interactive world is, in a VR experience, if I have a digital character, say we digitize you and we're not driving you live with your own body and face, but you're a pre-calculated performance, performances have to be context-based within a video game or a VR experience. If that's meant to be a non-player character that you interact with, that isn't you, but one of your companions or somebody who tells you a story. In VR, you can get really close to somebody. In the real world, if you do that, they'll back off and feel creeped out. That requires a brain. And the current state of the art on artificial intelligence for all games, including what we do, is based on combat mechanisms, simple state transitions that allow a non-player character to go from one mood to another. It's not the same as what happens in here. So I think there's a ton of work that needs to be done in terms of brain processing, neural net processing, whatever it ends up being, to add a personality to these characters and make them react in believable ways for human beings or whatever other creatures you're trying to visualize. Obviously, virtual reality, you're in a three-dimensional space. You want people to believe the space. Whether you have a stylistic art style you choose or a photorealistic art style, you still have to get all the cues that your brain expects for lighting within a world to believe it's a real space. So it's definitely going to push the envelope when it comes to our rendering technology. The performance requirements are through the roof for VR. There's a lot of work we have to do to make sure things run at speed. Thankfully to NVIDIA and AMD, the graphics technology gets better every year, and that's helping. But one of the things that we really love is it sort of changes the game in terms of the way you want to create. So obviously it's a great experience for consumers to go inside a virtual world, interact with a character, start to use physics in a live environment. Physics has been something we've had in games for a few years, but it doesn't get used tremendously well. In a VR experience, if you touch something, you expect to be able to pick it up or expect it to be knocked over if it's a small object, or if it's dangling, be able to, bat it backwards and forwards. It's totally natural in the real world. It should happen in virtual reality. So I think it's very exciting because I think it's going to drive physics and man-machine interactions. But one of the coolest things that occurred to us is, we've been doing experiments on building VR demos for quite a few years now. And we have this situation where the artist is, oh, I'm in VR checking out my thing. Oh, I got to move something. Oh, I got to change something. Take them off. Look at our editor. Move things around. So Tim and Mike Fricker, Tim's our CEO, they're like, this is ridiculous. I can't believe we're making people do this. So we started some experiments over a year ago. What's it like to actually manipulate and build worlds in the editor inside virtual reality? And actually, it's really cool. It's very efficient. You actually get a better context than what you would do looking at things on a 2D screen. But then you start to think, well, hold on. Now we can it actually makes more sense to use physics to place objects. What about a paint, like painting an object? Well, right now, we'll go into a traditional paint program or a traditional modeling program to manipulate an object. In VR, you start to get, well, surely I can just pull this around and sculpt it and move it. So I think what we're going to see over the next couple of years is a whole new range of tools companies, and whether they be the existing companies or new people straight out of school, people with great ideas, start to want to build tools that actually work inside virtual reality, but not as a separate process, but something that actually works in the world of the game engine. So I think it's going to be a pretty exciting time. I think, honestly, with FMX, I think it's a thought-provoking conference. We all come together, especially if you're a speaker. There's this wonderful speaker lounge at the top of the building. So there's a lot of, people with loads of experience in all different industries mingling together, and it really makes us think about what is the future. What have you been doing? Have you seen this? Have you seen? It's actually there's a lot more social time at FMX. So you really get time to share ideas, talk about the future, share experiences, and I actually think that many sort of decisions or ideas get seeded here at FMX for the next year and the years beyond. So I actually find it a very great place for sort of catalyzing and culturing, the next generation of cool things. And because there's such a heavy student component here as well, that whatever you show, whatever you do, and how you communicate to the audience, it's going to sort of inspire the next level of filmmakers or virtual reality people. And now, you can see that people are thinking, oh, am I going into film? Am I going to VR? No, I'm going to go into creative arts that could be interactive and could be passive, but I'm not going to limit myself. It's really cool to see this conference sort of sculpt the future of creative talent.